Hello, very good morning. Today our class is IP address classes and IP subnetting. In the last class we have seen TCP/IP addressing scheme and different addresses. What is meant by addressing and TCP/IP addressing scheme we have seen and we have discussed. So in this class we are going to see the IP address classes and IP subnetting. So know IP address classes and understand IP subnetting. So before going to see IP address classes and IP subnetting, so once we remind our what is meant by TCP/IP addressing and everything. What is addressing here? If you see, the primary job of IP is delivering messages between devices and like any good delivery service. And one of the most important functions of the internet protocol is addressing. IP addresses are used not only to uniquely identify IP addresses but to facilitate the routing of IP datagrams over internet networks. Because number of devices, lakhs of devices, millions of devices are connected in the internet. Each and every device which is connected in the internet must have an identity that is called IP address. So this IP address helps to route the datagram, facilitate the routing of datagram. It also identify the device by giving some address. TCP/IP includes an internet addressing scheme that allows users and applications to identify a specific network or host to communicate with. The internet address works like a postal address, allowing data to be routed to the chosen destination. And this also provides standards for assigning addresses to networks, subnetworks, hosts and sockets, and for using special addresses for broadcasts and local loopback. Here in the last class we have seen about this TCP/IP addressing scheme. TCP/IP uses a 32-bit addressing scheme to identify the devices on a network. So as we said, every device which is connected in the internet or network must be given some identification to identify the system or to send the information to the system or to communicate with the devices which is in the network. We must require identity. That identity is IP address. So this IP address scheme uses 32-bit addressing scheme to identify the device. So these 32 bits are divided into 4 octets of 8 bits each. So each of these 4 octets is represented in a decimal form and separated by a dot. Example 198.172.168.10 is an IP address. And this format of representing IP address is called the dotted decimal format. So here we can see one of the addressing, TCP/IP addressing 192.168.10.10. As these 4 sets, this 192 it's an octet, 168 it's an octet, 10 is an octet, and again 10 is an octet. So 32-bit addressing is represented in this form, and this is called dotted decimal format. So here also we can addressing the structure of IP address. So octet 1, the representing values for each binary digit 1, 2, 4, 8, 16, 32, 64, and 128. Like this, for each and every octet, we can represent the values here. And there are 4 octets, total 32-bit IP address. So if you give an example like this binary address 11000000 like this, so we can calculate a number with the value of this binary number, decimal value of binary number 64 and 128. This is 192, and for second octet there is one represent on 128 value, and again one represents for 32 value, again one represents for 8 value, and these three put together we are getting 168 here. And here in this octet only one is present, and for this only one we are taking, and here two ones are there. First one represents 1 value 1, and this one represent value 4, so these two put together we are getting 5. So in total we can represent this as 192, 168, 192 dot, 168 dot, and 1 dot, and 5. This is dotted decimal address. So this representation is used in the TCP/IP addressing scheme. So IP address, once we see the IP address terminology, various terms used to represent IP addresses. So first one, IP address, a unique 32-bit number assigns to any device connected to a network. Devices such as laptops, of course also called hosts, usually have only one connected interface, that is either Ethernet or wireless, while more complex equipments like routers could have several interfaces connected to different networks. Each of them require a unique IP address assigned. So network part, a portion of the IP address that determines the subnet. Host part, portion of the IP address that identifies the host within the subnet. Subnet, network obtained using a portion of a bigger network. Subnet address, IP address that identifies a specific subnet. Subnet mask, a bit mask used to understand which part of the IP address is the network part and which one is the host part. Interface, a connection to the network. It can belong to host or to a router. So these are the terms generally used in the IP address terminology. So far we have seen just what is IP address and what bits are represented here. How many bits are represented? 32-bit addressing scheme here we are applying in the IP address scheme, and these are the terms used in the IP address terminology. So now our main topic, IP address classes. What is IP address classes? Internet protocol hierarchy contains several classes of IP addresses to be used efficiently in various situations as per the requirements of hosts per network. There are classes to used efficiently in various situations. So what are the classes used in the IP address format? An IP address class is a categorical division of Internet protocol address in IP-based routing. It is categorical. The Internet addresses are allocated by the NIC, the organization that administers the Internet. These IP addresses are divided into classes. IP addresses are divided into 5 classes that are identified by the value of the first octet, the first decimal number. The system of IP addresses classes was developed for the purpose of Internet IP address assignment. These classes created were based on the network size. So what are these classes we see now? TCP/IP defines 5 classes of IP addresses: Class A, Class B, Class C, Class D, and Class E. So there are 5 classes. Each class has a range of valid IP addresses here. The value of the first octet determines the class. We can identify the class by seeing the value of the first octet. The address classes divided the address space into the addresses that support large number of nodes intended for a large organization use class A addresses. Medium number of nodes uses class B addresses. Small number of nodes intended for small organization uses class C addresses, and class D and E are reserved. So there are 5 IP address classes: class A, class B, class C, class D and class E. Separate IP classes are used for different types of networks. Why these are categorization is done means these separate IP address classes are used for different types of networks. Some are used for public internet accessible IPs and subnets, that is those networks behind a router as in class A, B and C. As well, some classes are resolved by the Internet Engineering Task Force (IETF) and the Internet Assigned Network Numbers Authority (IANA) for specific purposes. These special ranges are used for multicasting of identical data to all computers on a network or subnet, or for research as in classes D and E. It means generally the classes A, B, C are used for networks, whereas classes D and E are used for research purpose. The IP addresses from the first 3 classes A, B, C can be used for host addresses. The other 2 classes are used for the other purposes. Class D for multicast and class A are for experimental purpose, nothing but research purpose. The system of IP address classes was developed for the purpose of Internet IP address assignment. The classes created were based on the network size. Example, for the small of networks with a very large number of hosts, the class A was created. The class C was created for numerous networks with small number of hosts. So like this, based on the requirement of the network size and everything, we are using different classes based on the requirement. Whether requirement of if number of hosts are high, then we use class A. If the number of networks are high, I mean huge number of networks we are using, we use class C. So the IP address is divided into 2 parts. Generally, any IP address, the 32-bit IP address is divided into 2 parts, that is network ID and host ID. The class of IP address is used to determine the bits used for network ID and host ID and the number of total networks and hosts possible in that particular class. So here we can see the different IP address classes as class A, class B, class C, class D and class E, and these are 4 bytes are there, nothing but it is 32-bit addressing. And in this class A, the first byte is used for network ID and remaining 3 bytes are used for identifying the host. In class B, first 2 bytes, byte 1 and byte 2, used for identifying the network, and byte 3 and 4 used for identifying the host. In the class C, first 3 bytes, byte 1, byte 2, byte 3 are used for identifying the network, and last byte, that is nothing but byte 4, used for identifying the host. And class D used for multicast address, and class E is reserved for research purpose. So these are the details about all the IP address classes: class A, class B, class C, class D, and class E in the class. So if you we see now all the details about all the classes: class A, B, C, D, and E. So IP address class A, first we will see. The IP address belong to class A are assigned to the networks that contain a large number of hosts. So any network, if you are establishing a network with large number of hosts, generally we use class A addressing scheme. The network ID is 8 bits long in this class A, and the host ID is 24 bits long. The first bit of the first octet is always set to 0. That is nothing but this one. Always set it to 0 here, first octet, first value. Thus the first octet ranges from 1 to 127. That is like this. We can say this is this bit identifies that it belongs to class A address, and the value ranges from 1 to 127. This 7 ones represents 2 to the power of 7 is equivalent to 127. So here 7 bits represents decimal value of 127. The higher order bit for the first octet in the class A is always set to 0. So this is always set to 0, higher order bit. The remaining 7 bits in the first octet are used to determine the network ID. Here remaining 7 bits are used to represent network ID. The 24 bits of the host ID are used to determine the host in any network. The default subnet mask for class A is 255.x.x.x. Therefore, class A has a total of 2 to the power of 7 minus 2 is equivalent to 126 network ID. Here 2 address is subtracted because 000.0.0 and 127.x.y.z are special address. And 2 to the power of 24 minus 2 is equal to 16,777,214 host ID. IP addresses belong to class A ranges from 1.x.x.x to 126.x.x.x. The class A IP addresses where the first bit is 0 encompasses the range of 0.0.0 to 127.255.255.255. This class is for large networks and has 8 bits for network and 24 bits for hosts. So like this, in the 32-bit address of class A, the first 0 indicates that identify that it is a class A address, and 7 bits are used to identify the network, and remaining 24 bits are used to identify the host. So here also we can see class A IP address 77.171.51.13. If we represent this in binary number system, the bits 0, this indicates class A identifier, and remaining 7 bits indicates identify the network address, and remaining these bits are used to identify host address. So like this, class A address is used. The first bit is class A identifier, and remaining 7 bits are used to identify network, and remaining 24 bits are used to identify host. So here also we can see class A address 7 bits are available for network ID. Bit 8 is always 0. This one bit 8 is always 0. So 7 bits are available. These 7 bits are available, and 2 to the power of 7 is equivalent to 128 networks we have. And remaining 24 bits are available for host ID, This is nothing but 2 to the power of 24 is equivalent to this much hosts. So class A network uses 7 bits for the network ID, whereas the host ID uses 24 bits. The more bits used, the greater the number. This is why class A networks can have so many hosts and therefore are used for large networks. Class A is used for large networks where number of hosts are there. So next one is class B. The IP address belonging to class B are assigned to the networks that ranges from medium sized to large sized networks. In this, the network ID is 16 bits long and the host ID is 16 bits long. An IP address which belongs to class B has the first 2 bits in the first octet set to 10. So in this 10, this 10 indicates that it is class B address. So remaining bits, it ranges from 128 to 191. The higher order bits of the first octet of IP addresses class B are always set to 10. This is nothing but 10. Here 10. So by seeing this, we can identify that this IP address belongs to class B. The remaining 14 bits are used to determine network ID. The 16 bits of host ID is used to determine the host in any network. The default subnet mask for class B is 255.255.x.x. So class B has a total number of 2 to the power of 14 is equivalent to 16,384 network addresses, and 2 to the power of 16 minus 2, that is nothing but 65,534 host addresses. So because here we are taking 14 bits from the first 16 bits, the 102 bits are used to identify the class B address. IP addresses belongs to the class B ranges from 128.0.x.x to 191.255.x.x. Class B networks use default subnet mask of 255.255.0.0 and have 128 to 191 as their first octet. The address 172.16.52.63 is a class B address. This is example. Its first octet is 172, which is between 128 and 191 inclusive. So if we see out of 32 bits, the first 2 bits 10 identify the class B address as class B address, and remaining 14 bits in the after 2 bits, 14 bits are used to identify the network and 16 bits are used to identify the host in class B. So if we take an example 131.171.51.13, so in this, if you convert these numbers into binary, this 10 indicates class B identifier. The 10 indicates that it is a class B identifier, and remaining are network address, and these are 14 bits from this to this number. 14 bits are used to identify network address, and these 16 bits are used to identify host address. So like this, so class B can be seen here, whereas wherein among 32 bits, the first 2 bits are class B identifiers, and remaining next 14 bits are used to identify network address, and last 16 bits are used to identify host. Class C address. The IP addresses belongs to class C are assigned to small size networks. The network ID is 24 bits long and the host ID is 8 bits long. The first octet of class C IP address has its first 3 bits set to 110, that is, here we can see The 110, these 3 bits identify that this is class C address. So class C address starts from 192 to 223. The IP address starting IP by seeing that 32-bit address, the first octet, if it is between 192 and 223, we can say it is class C address. The higher bits of the first octet of IP addresses of the class C are always set to 110. This is the higher bits of the IP address. By seeing this, we can say it is class C address. The remaining 21 bits are used to determine the network ID. The 8 bits of the host ID is used to determine the host in any network. The default subnet mask for class C is 255.255.255.x. The class C has total of 2 to the power of 21, because here among the 24 bits, 3 bits are used to identify, indicating that the address is class C address, and remaining 21 bits in the first 3 bytes. So 2 to the power of 21 is equivalent to 20,971,052 network addresses we can assign. So remaining 8 bits, 2 to the power of 8 minus 2 is equivalent to 254 host addresses. So IP addresses belongs to class C, ranges from 192.0.0.x to 223.255.255.x. So class C networks use a default subnet mask of 255.255.255.0 and have 192 to 223 as their first octet. The address example 192.168.123.132 is a class C address. Its first octet is 192, which is between 192 and 223 inclusive. So if we see out of 32 bits, here we can see the first 3 bits are used to identify it is a class C address, and in the next 21 bits are used to identify the network ID, and the remaining 8 bits are used to identify the host. This is class C addressing. Here one of the example 205.171.51.13. If we convert to the binary number, the first 3 numbers 110 is class identifier, and remaining 21 bits are used to these numbers, and 8 plus 5, 13 plus 8, 21. These 21 bits are used to identify network address, and remaining 8 bits are used to identify host address here. So this is about class C addressing. And if we analyze class C of network, here 21 bits are available for network ID. Bit 8 to 6 is always 110. This is 110, and remaining 21 bits from this bit are nothing but 2 to the power of 27 is equivalent to 2,97,152 networks, and 8 available bits are used for host ID, that is nothing but 2 to the power of 8 is equal to 256 hosts. So class C networks use 21 bits for the network ID and 8 bits for the host ID. This is why class C networks have a large number of networks, but with the only 256 hosts per network. So this is about class C IP addressing scheme. So another example we can see here, there is a router with 192.168.0.1 as a server, 192.168.0.6, and remaining hosts are identified with 192.168.0.3, and here 0.4 and 2 and 5. Here the host ID is 2, and network ID is 0, 192.168.0. This is class C. The above class C network has a network ID of 192.168.0 and host ID is nothing but 2. So this is nothing but network ID 192.168.0. This is network ID and 2 is host ID. So if we compare class A, B, C, here class A first 8 bits are used for network ID and remaining 24 bits are used for host ID. And in class B, first 2 bytes, nothing but 16 bits are used for network ID and remaining 16 bits are used for host ID. In class C, first 24 bits are used for network ID and remaining 8 bits are used for host ID. And class D, IP address class D, the IP address belongs to class D are reserved for multicasting. The higher order bits of the first acted IP addresses belongs to the class D are always set to 1110. The remaining bits are for the address that interested host recognize. Class D does not possess any subnet mask. Class D does not have any subnet mask. IP address belongs to the class D ranges from 224.0.0.0 to 239.255.255.255. So very first 4 bits here, first 4 bits 1110. First acted in the class D IP address are set to 1110, giving the range of 224 to 239. So class D has IP address ranges from 224.0.0.0 to 239.255.255.255. Class D is reserved for multicasting. In multicasting data is not destined for a particular host. That is why there is no need to extract host address from the IP address, and class D address does not have any subnet mask. So here, out of 32 bits, the first 4 bits are used for identifying that, indicating that it is a class D address, and remaining 28 bits are used for host. And class E address, the addresses belongs to the class E are reserved for experimental and research purposes. The IP addresses class E range from 240.0.0.0 to 255.255.255.254. This class does not have any subnet mask. The higher order bits of the first acted class E are always set to 4 ones 1 1 1 1. This IP address class is reserved for experimental and R&D research and analysis, research purpose and study purpose, and used for especially experimental and research and development and also study. IP addresses in this class ranges from 240.0.0.0 to 255.255.255.254. Like class D, this class 2 is not equipped with any subnet mask. So class D and class E does not have any subnet mask with them. And so out of 32 bits, the first 4 bits are set to 1 1 1 1 1, and remaining 28 bits are used for host ID. So here we have seen 5 classes of addresses: class A, class B, class C, class D, and class E. So how to find that a particular address belongs to a particular class. By seeing any address, we can say that particular address belongs to some particular address class. So to find the class of an IP address, simply pay attention on the first octet. We have to see the first octet. If the value of first octet is in the range 1 to 127, it's a class A IP address. Example, the class A IP addresses are 1.2.3.4, 10.20.30 and .45, 125.234.123.23, 126.100.200.45, etc. If the first value of octet is in the range of 128 to 191, it is class B IP address. Example 128.200.100.50, 191.20.200.100.1, 172.168.0.1, 175.45.48.14, etc. So here, if you see the first value, in this case B, the value between 128 to 191. This is 128, 191, 172, 175, all in the range of 128 to 191. Here also in case of class A, this first number 1 and here 10 and 20, 125 and 126 are in the range of 1 to 127. That's why it's a class A addresses. Next, if the value of the first octet in the range 192 to 223, it's a class C IP address. Examples are 192.168.1.1, 200.0.0.1, 223.224.127.1, 212.14.15.56, etc. So if you see the first octet, these are 192, 200, 223 and 212 are in the range of 192 to 223. So that we can easily find out which class of IP address is. So here also we can see identify the network and host ID in the class A. First 8 bits are used for identifying the network and remaining 24 bits are used to identify the host. And class B, so it starts with 10, class A starts with 0, and here these first 2 bits are used for network ID and remaining 2 bits are used for host ID. Class G we can identify by seeing the first 3 numbers 110 and remaining bits are 21 bits are used for identifying the network and remaining 8 bits are used for identifying the host. And class D we can identify this the first 4 numbers 1110 that this is a class D ID and remaining all 24 bits remaining all 28 bits are used for network ID, and this is used in multicasting actually. And class E, by seeing the first 4 bits 1111, we can identify that is a class E address, and remaining 28 bits are used for network ID, but actually this class E addressing is reserved for experimental purpose and also R&D purpose. So for distinguishing class A, class B addresses, we need a way to distinguish a class A address from class B, C, D, E addresses. What is that? The method used was to use the location on the first 0 bit in the most significant bits by the first byte. If the first bit is 0, when we have a class A address like this, the MSB is 0, most significant 0, that's why we can say it is a class A address. So this means class A network address is always in the range of 0 to 127 and all zeros and all ones except first 0. And class B, the first 2 indicates that class B, this means that class B network address is always in the range of 128 to 191, and this 10 indicates that it is a class B address. So most significant bit is a 1 and the next 1 is a 0. So if we compare all the classes of IP address, class A leading bits are 0, class B leading bits are 10, and class C leading bits are 110, class D used for multicast 1110, and class E reserved, these leading bits are all ones. The size of the network of the bits field are 8 in the class A and 16 in the class B, 24 in the class C, and here class D and class E is not defined. And size of rest of the bits field is 24 plus hosts in the class A, 16 bits for host in class B, and 8 bits for host in the class C, and remaining for class D and E not defined. So number of networks in the class A, there is nothing but 128, there is nothing but 2 to the power of 7. Here in the class B it is 2 to the power of 14, and in class C it is 2 to the power of 21. And class D and class E are not defined. And the address for network are here class A 2 to the power of 24 hosts, and in the class B 2 to the power of 16 hosts, and class C it is 2 to the power of 8 hosts. Here in class D and E also not defined for networks. So total address class A in this class A is equal to 2 to the power of 31, class B 2 to the power of 30, because here first bit used for identifying the class A. In the class B, first 2 bits are used for identifying the class B. That's why we are taking out of 32, we are taking only 2 to the power of 30. And in class C, first 3 bits are used for identifying the class C. That's why we are taking 2 to the power of 29. And the class D, the first 4 bits are used for identifying, indicating that is a class D. That's why we are using 2 to the power of 28 total addresses. And here also 2 to the power of 28 total address in the class E. But here leading bits are 4 bits are used for class E identification. So here starting address for class E is equal to 0.0.0, and class B 128.0.0.0, and class C 192.0.0.0, and class D 224.0.0.0, and class E 240.0.0.0. So end address here 127.255.255.255, and class B 191.255.255.255, class E 223.255.255.255, and class D 239.255.255.255, and class E all numbers are 255.255.255. So these are the comparison among all the A, class A, B, C, D and E addresses, IP address classes. So here also we can see first octet value 0 to 127, that is A, 128 to 191 for B, and 192.223.223 to class C, and for class D 224.239, for class E 242 to 255. Here subnet mask is 8 bits, and in this case 16 bits for class B, and class C there are 24 bits subnet mask, but for class D and E there is no subnet mask at all. Here IP address classes range 1.0.0.1 to 126.255.255.254, supports 16 million hosts on each of 127 networks. Here in this case classes B 127.1.0.1 to 191.255.255.254 supports 65,000 hosts on each of the 16,000 networks. In class C 192.0.1.1 to 223.255.254.254 supports 254 hosts on each of 2 million networks. In the class D, the reserved for multi-class groups, and class E reserved for future use and research and development purposes. So how data is sent to an IP address and to another network? Here our computer connects to the router using TCP/IP and asks for the local address. The router responds and gives the computer the local IP address 192.168.1.12. The router requests an IP address to connect the internet. The ISP internet service provider assigns WAN address as 175.51.127.17. While on the internet, we request access to the computer home server by entering the using DNS. The address is translated to IP address, that is 69.72.168.9.241, and the IP TCP/IP packets travels over multiple routers and computers until it reaches that address. And TCP/IP packet reaches its destination, communicates with the other computer, responds and repeats the above steps to get the data back to our computer. So this is process of sending the data in the network. Subnetting, IP subnetting. What is meant by subnetting? Subnetting is the practice of dividing a network into 2 or more smaller networks. It increases routing efficiency, enhances the security of the network, and reduces the size of the broadcast domain. This is a subnetting. An IP address includes a network segment and a host segment. Subnets are designed by accepting bits from the IP address's host part and using these bits to assign a number of smaller subnetworks inside the original network. Subnetting allows an organization to add subnetworks without the need to acquire new network number via the internet service provider. Subnetting helps to reduce the network traffic and conceals network complexity. Subnetting is essential when a single network number has to be allocated over numerous segments of a local area network. Subnetting allows to create multiple logical networks that exist within a single class A, B or C network. If we do not subnet, we are only able to use one network from our class A, B or C network, which is unrealistic. Subnetting is a process of taking a network and splitting it into smaller networks known as subnets. It's used to free up more public IP addresses and segment networks for security and easier management. So what is subnetting here? The process of taking an extensive network and splitting it to smaller networks is known as subnetting. It is freeing up more public IP addresses. So it's splitting into smaller networks. Subnetting is nothing but dividing and splitting into smaller networks. Each data link on the network must have unique network ID, which every node on that link being a member of same network. If we break a major network class A, B or C into smaller subnetworks, it allows us to create a network of interconnecting subnetworks. Each data link on this network would then have a unique network at subnetwork ID. Any device or gateway that connects n networks or subnetworks has n distinct IP addresses, one for each network or subnetwork that it interconnects. What are subnets used for? Why we are using subnets? Subnets offer a way of organizing the network to help to reduce network congestion. When we have a lot of traffic flowing between particular parts of the network, it can help to group those parts in a single section. So the traffic does not have to travel across the entire network to get from place to place. Separating out small parts of the network into subnets allows traffic to flow more quickly and to avoid taking unnecessary routes, adding traffic where it is not needed. In addition, subnetting helps in efficiently allocating IP addresses and prevents large numbers of IP addresses from going unused. This is the most important factor. Subnetting helps in efficiently allocating IP addresses and prevents large number of IP addresses from going unused. Subnets are usually set up geographically for a particular offices or for particular teams within a business to allow their network traffic to stay within the location. So for these reasons we are using subnets. So how many hosts can we have in our subnet? Determining how many hosts can have in the subnet is important. As we don't want to end up with the subnet too small to host, all the IP addresses we have need are one too large and resulting in a lot of wastage. That's why how many number of subnets we have in a host, we have to see. We can figure out how many hosts we can have in our subnet by subtracting the number of network bits from the number of total bits. There are 32 total bits minus the number of network bits. Example, we use 26 an example. A subnet with 26 network bits has 6 bits available for the host IP addresses. We then also need to subtract 2 IP addresses from the network IP itself and then broadcast address. So the formula is 2 to the power of 32 minus 26 and minus 2 is equivalent to 2 to the power of 6 minus 2, that is nothing but 62. In case of 26, the network bits are used in this example. So we can use this with any number of network bits to determine how many bits we have available to create hosts for our subnet. So main formula, among 32 bits total bits minus the number of network bits. So here 26, take example, there are 26 network bits. So we are subtracting this 26 from 32. Like here 32 minus 26, so total 2 to the power of 32 minus 26 is equivalent to 6 we are getting, and 2 to the power of 6 minus 2, because 2 subtracted addresses for the network IP itself and the broadcast address. That's why we are taking this formula, we are getting 62. Here in this case 62 subnets we have in this particular host. So this is all about IP address classes and IP subnets. We have discussed it in the lengthy. What are the IP address classes? There are 5 classes: class A, class B, class C, class D, and class E. Class A, class B, class C are used for networks generally, and class D are used for multicasting, and class E used for research and development purpose. And what is subnetting? Subnetting also very much useful. Subnetting divides and split the larger network into smaller networks. So we can determine how many subnets in a particular host by using this formula. So this is all about IP address classes and also subnetting. Thank you.